So good morning, everybody. How is everybody doing? Is everybody doing well? Please give me a thumbs up if you're doing well. I can see a few people in the order. Great. Okay, you're excited. I am excited too. This is a new talk, and it's the very first time that I am giving it. So I want to start with a little imagination. Suppose you're walking in a dark forest. It's really dark. You've lost your way. You're trying to get home. And suddenly you get to a clearing in the forest. I hope it shows up on the screen. I can't see through the video, but there should be a dark forest on the left. And suddenly you see this armchair in the middle of the forest. What are the thoughts that this would cause you? What is the feeling that this would give you, suddenly seeing this chair in the middle of the forest? Probably, what Piaget would have called a cognitive dissonance, maybe a sense of fear. Who put this chair there? Why is that chair there? Is there somebody who might attack me? Our wires, our brains are wired to make sense out of chaos, to try to understand the world around us and how things work. I thought it'd be interesting to ask ChatGPT this exact same question. And you know what? This is what ChatGPT replied. A quick grin. It's absurd. The forest momentarily pretends to be a house. The clearing becomes a room with a sky for a ceiling. Who sat there? A hermit reading Thoreau? A fox using it as a lookout? A storm refugee? Is it covering a wasp nest? Poison ivy creeping up the legs? Ticks in the upholstery? Sittings suddenly seems unwise. I kid you not. This is how ChatGPT reacted to this scenario. I then asked it to describe its emotions, and I didn't get much further. It's very clear that there are major differences between biological and artificial intelligence. And not just this difference I just pointed out. The brain on the left works on 25 watt of energy. ChatGPT on the right required thousands of megawatt of energy to function. The brain on the left evolved over millions of years. ChatGPT over just a few decades. And it should come as no surprise that ChatGPT gave these disappointing answers to the scenario, because large language models are nothing more than a souped up statistical regurgitation machine. Yet, they are sometimes surprisingly good at drafting essays, at solving problem sets, at mimicking human feedbacks. And they can do it faster and cheaper than any human being. In fact, AI makes good enough cognition cheap. And that raises the bar for what universities must cultivate. And for us in education, you and me, it causes what I call the education problem, which has two major facets. The first one is that AI is very rapidly changing the workplace demands. Our students, your students, and my students are going to enter into a workplace that is very, very different from anything you and I have known. And at the same time, AI exposes problems in education, not new problems, but problems that have been all along, but that we have ignored. And AI makes these problems irrefutable. And if we don't do something about it, we're going to pay a big price. Let's talk about the first one very briefly, and then I'll focus most of my talk about the second point that is on the screen there. Why would an employer hire a 22-year-old university graduate if AI can do the work instead? And as I already pointed out, AI can do reasonable cognition, good enough cognition, very quickly and very cheaply. And in fact, recent data from the Harvard Business School show that this is already impacting the fragile job market for college graduates. You can see here how the unemployment rate in the US increased for different attainment level. At the high school level, for college dropouts and for people who have an associate's degree, unemployment has increased a little bit, but it is within statistical noise. But if you look at college graduates with a bachelor's degree or with a graduate degree, the unemployment has gone up dramatically. In fact, it's the highest unemployment, precisely for the reason that is shown there at the top. So if we don't teach our students the skill that they will need in the future workplace, we're devaluing the meaning of a university education. Now, on to education, because that's what I really want to focus on. AI can do a lot of what we ask our students to do. In fact, 2 years ago, I fed my assignments in my course to, the precursor of ChatGPT, and it was very mediocre work. But this year, it can do absolutely everything I ask my students at Harvard to do, which means that AI provides a tempting shortcut for the students. So what do we do about it? Well, I'm going to talk to you, divide my talk into 3 parts. First, I'm going to talk about motivation, because I think that motivation to learn is the key thing. And I just talked about the innate motivation to learn that we have as human beings, is the key to developing a AI resistant or AI resilient, I should say, curriculum that teaches students the right skill. Then we'll talk about what type of class activities make sense in the time of AI. And finally, what we need to do about the evaluation of students. So let's start with motivation. Nobody in their right mind would pay for a gym membership and then send a robot to do the workouts for them. Yet, students enroll in the university, and in the US, they pay a hefty sum for that. And they're all too happy to hand in work that is done by AI. Why? You buy a gym membership, you want to improve yourself, you work out. If you don't work out, you don't improve yourself. You enroll in a university because you want to improve yourself and, have a better chance at success in the job market. Yet the temptation is big to use AI. Is this a problem with our students? No, it's really a problem with education. And with motivation in particular. And so the question is, how can we drive a stronger engagement the same way that people go to gyms and sweat and work out? Well, maybe there's something we can learn from gaming. We all know that students get, or not students, people in general, you, I, everybody, can get extremely addicted to gaming. And, wouldn't it be nice if we could drive the same type of engagement as we get in gaming? And you only have to look at small children to know that this is possible. Look at small children. They keep asking why. That one question, why, W-H-Y was a question mark, keeps coming back over and over again. And it's sort of a sad fact that education, as they go through kindergarten, elementary school, and then high school, beats it out of them, that curiosity. And when they come to us at the university, they simply ask, what do I need to do in order to pass the test? Rather than, how can I understand this? So 5 years ago, I invited a learning designer from Stanford, from the Stanford D School, to come and give a talk at the Learning Incubator in Harvard about how game designers design their games, because I was hoping to learn something from that to put into education. And she started her talk by asking the audience, what do you think is the key to hooking gamers to games? What is the key principles of gaming design? We all looked at each other in the audience and we said, we don't know. This is what we came to know. And she said, it's learning. It's mastering skills. So here I invited this person to see if we could use principle from gaming to inform education, only to find out that actually education is what is informing gaming, which shows that we have a major problem in education, because if in gaming you can use the gaining of mastery of skills to get great engagement, then we're missing the boat in education. Well, it turns out that if you dig a little bit deeper into game development theory, you find out that they pay a lot of attention to something called self-determination theory. And self-determination theory says that human beings have three basic psychological needs. People need to have a sense of growth, that they're advancing in their knowledge, that they're managing to figure things out. They need a sense of autonomy, that they're gaining, that they're having that sense of growth because of their own actions. And lastly, because they have a need for a sense of relatedness, that they are part of a community of learning, or that whatever they're doing helps society at large. The game design principles are on this next slide that I have here. Oops, what is happening here? There. The game needs to have clear learning goals. It has to have a meaningful progression. So far, it looks pretty much like, curriculum design. It has to offer feedback and rewards. It needs to have dynamic difficulty adjustments so that, for no player, it becomes too difficult to progress. There we already see some divergence from education, because we try to take all of our students and put them on a conveyor belt, all moving at the same pace through the curriculum. And last three items are: we need to encourage exploration, which we definitely want to do in education, but which doesn't happen very much. We want to have a balance and a pace so that it doesn't exhaust people. And finally, in gaming, and this is really important in many modern games, there has to be a social connection, which is why most games nowadays have a social connection. Those first four goals are related to growth. The next two are related to autonomy. And the final one is related to social connection. So back to motivation for a moment. There are two types of motivation. Actually, there's a scale of motivation that goes from one side, an extrinsic motivation, to the other side, to intrinsic motivation. Extrinsic motivation means I'm doing it to gain a reward or avoid punishment. I'm studying because I have to take a test. I'm working hard in this course because otherwise my parents will be upset at me. That's extrinsic motivation. And then there's intrinsic motivation. I'm doing it because it is inherently interesting, satisfying, or enjoyable. And in a sense, the activity is the reward. And of course, what decides this spectrum between extrinsic and intrinsic motivation, and you probably recognize that most of your students are in the extrinsic motivated category, is the degree of self-determination, which is very low on the left side of this diagram and high on the right side of this diagram. So let's start with some bad news. What is self-determination in a traditional course? Traditional course typically has a lecture and then homework and then an exam. What about the lecture? What about gross autonomy and relatedness? That's what you see in each of these bar diagrams, in a lecture, in a homework, and an exam. Well, imagine you're in a lecture and you are sitting in a lecture right now. What about growth? Well, maybe you may have some aha moments here or there, but not many. What about autonomy? You're completely controlled by the instructor, me. I set the pace. There's no autonomy that you have there. What about relatedness? Well, you're sitting with other people in the lecture room, but you're not interacting with them. Maybe from time to time you whisper to them, but you're mostly stuck listening to me. So, in terms of self determination, things are pretty low. What about homework? Well, doing the homework, you may occasionally maybe have an aha moment. Ah, now I get this. But as we know, students often go through homework by rote, mechanically approaching their homework without really figuring things out. What about autonomy? Well, you can decide when you do your homework, but it's your instructor who tells you to do it. And what about relatedness? You're essentially alone because it's an individual assessment. And what about, and of course, with AI, everything drops to zero. No growth, no autonomy, no relatedness, no self determination, no intrinsic motivation whatsoever. And an exam similarly scores extremely low. If you have a growth during the exam, it's probably too late. If you think of autonomy, there is no autonomy in an exam. And on top of this, education research, including my own, but there's a lot, show that there is very disappointing learning gains in any traditional approach to teaching. Now, the good news is that you can change motivation by designing for self-determination. You can actually also easily measure self-determination, and I highly recommend that you do that in your courses to see where you are now and where you'd like to go. One instrument is this 5-question agile survey developed by Robert Talbot. The reference is at the bottom of the screen. It asks 5 questions that you can ask at different points in your course or relating to different activities you do in your course. The first question says, I was challenged intellectually over the past week or by this assignment. You can add there whatever you want. I had plenty of support from the teaching staff and from my classmates and from the materials in the past week or past months or for this activity. I am closer to mastering the ideas of the course now than I was a week ago. I made progress because of my own efforts and choices. And the last one is I felt I was part of a community of learners. The first one deal with the balance between challenge and support. And you want to be sure that you both challenge your students and that you also support them. I'm not going to talk about those. I want to focus on the last 3, which, as you can see, deal with those 3 dimensions of self-determination: growth, autonomy, and relatedness. And data that I obtained in my own course when I wanted to improve my course show that it actually is possible to improve growth, autonomy, and relatedness. Here you see how students responded on a scale from strongly disagree at the bottom to neutral in the middle to strongly agree all the way at the top. And as you see, my students were pretty neutral about all those 3 dimensions when I started thinking about self-determination. And this was already after I had made some changes to the course. So I decided to make many more changes. And look, everything went up. And there were additional gains. There was deeper learning that resulted in greater learning gains. There was greater engagement and participation. Almost all of my students came to class. Normally in a lecture-based class, what? 60% show up? Now 95% showed up. Students even came to class when they were sick and should really have stayed home. Higher self-efficacy. I measured gains in self-efficacy, which I'd never measured. So students coming out of my course were coming out with a bigger belief in being able to do physics, a greater sense of purpose, understanding where what I taught them fit into their worlds, higher course satisfaction, and much less shortcuts which is a word I use because I prefer that over the word cheating. So how do we make this transformation? Let me get to the second part of my talk, class activities. So we already talked about lectures, which focus on information transfer. Mostly students sit, like you are sitting there right now, passively absorbing what I'm saying, maybe taking notes. And as we already said, growth, autonomy, and relatedness are all very low. But education is not just information transfer, right? It's not just putting the information in the brain so that students can recall that information later. If that's all we do with our students, then they're all going to be replaced by computers because computers do this much better than human beings. No, education is a two-step process. Yes, you need information transfer, but the learner needs to make sense of this information, have the aha moments that make it possible to apply what you've learned in a new context. And this aha moments, that's exactly what gives the feeling of growth and autonomy. It's the hook that keeps gamers come back and back and back to play more games because they want to have the adrenaline rush of these aha moments. Now, in the traditional approach to teaching, the information transfers in class in the form of a lecture, and the sense-making takes place at home, in the form of homework or study. And we instructors are focusing on what I would call the easy part of education, information transfer, whereas we should really be helping our students make sense of the information, build the mental models that are going to make them critical thinkers that can use AI critically to accomplish more than either one could accomplish alone. Now, some of you who've heard me speak have heard some of this before because many, many years ago, more than 3 decades ago, I developed an approach to teaching, peer instruction, which is a form of active learning that actually connects the two, the information transfer and home, increasing self-determination. When I did this, I never connected it to self-determination theory, but now I can see the connection. And in peer instruction, rather than teaching by telling, like I'm doing with you now, we teach by questioning. So I pose a question, I ask students to think about the question, silence, and then I poll them quickly. And finally, I tell them, now turn to your neighbor and discuss this question with your neighbor. I poll them again. I end with an explanation, which can come either from the student or from me, and then this cycle repeats. But the important point is this discussion, because that's where the aha moment happens. That's when students go, oh, I figured it out, because they've had time to think about the question. And as I said, the cycle repeats many times. And I thought, maybe I'd demonstrate this with you. It's going to be a hard question, but I'm going to prepare you for that hard question. But I want some of you, I can't promise that all of you, but at least some of you will have an aha moment and get something out of this exercise. And I want you to also see how different this is from an ordinary lectures. And I want to pick a subject that we all know something about, probabilities, and that we're reasonably okay at in simple cases, but I know many of us struggle with in more complicated cases. Think of a dice and ask yourself, if I have a dice and I throw a dice, what is the probability of throwing a 6? Well, there are 6 different possibilities. So 1 in 6, if the event is completely random, 1 in 6 events should yield a 6. So if I throw it 6 times, I should have a reasonably good chance of getting a 6. If I throw it once, I only have 1/6, which is about 16% chance of throwing a 6. But now ask more complicated things is, let's say you have two dice. What is the probability of throwing two sixes? Well, let's work it out together because it'll tell us something about combined probabilities, which my question will be about. If you have one dice, the probability of throwing a six is 1 out of 6. If you then throw the second dice, the red dice, the probability of throwing a six is also 1/6. But you throw them together. So let's say that you throw them together and the blue dice becomes a 1. Then there are 6 different combinations, one of which will have a 6. If you do a 2, the same thing. There'll be one that has a 6. If you throw a 3 or a 4 or a 5 or a 6 with the blue dice, there will be one that has a 6. But there's only one out of those 36 combinations that has two sixes. So the probability of throwing two sixes is 1 in 36 throws on average. Notice that 1 over 36 is just a product of 1 over 6 times 1 out of 6. So what does that tell us? That tells us that if you have two events, one event, for example, throwing a 6, and another event, throwing another 6 with another dice, and each of these have two different probabilities, well, in this case, it's 1/6 and 1/6, then the probability of both of those happening is the product of those two probabilities. So, right? Red dice, 1/6, blue dice, 1/6, red and blue dice, both 6, 1/6 times 1/6, which is 1 over 36. So let's say that you look in the news and the chance of rain today in Lima is 70%, but you know that on average you forget your umbrella 30% of the time. What is the chance that you get caught in rain without an umbrella? Well, it's 0.7, 70%, times 0.3, 30%, which is 0.29. You'll have a 21% chance that you'll get caught in rain, 1 in 5 roughly, without an umbrella. Questions, anybody? I think I gave a pretty good lecture, right? And I've worked hard on this, so, on how to visualize this. And I want to point out that I'm glad to see a thumbs up there. Thank you so much. I want you to point out that, yes, it may have been a clear lecture, but would you be able to already answer my question? Let's see. Here's my question. The weather forecast calls for a 70% chance of rain in London and a 40% chance of rain in Chicago. Those are some very reasonable numbers. Now the question is this: which of the following scenarios is most likely? 1, it rains in London. Well, that's easy. We already know what the percentage of rain in London is, so 70%. So there's a 70% chance for this. It rains only in Chicago and not in London. It rains in London and in Chicago. It rains in London or Chicago. So I want you to take a minute. You may want to take a piece of paper and write things out, because I would not be able to solve this problem without making some notes and some sketches here. So think about this, and at least I want you to calculate the chance that it rains in London and in Chicago. And then maybe you can think a little bit about the other two scenarios as well. I'll give you 2 minutes. Don't talk to anyone, okay? I want you to do it by yourself. You're going to get a chance to talk to your neighbor in a second, but you have to work on your own first. A basic principle of pedagogical design. 30 seconds left. And it's a hard question, I know, It's okay. I'm stretching you, and this is important education. We want to challenge. So if you haven't been able to completely work it out, don't worry. It's not going to affect your salary, or your life or anything. And I'm not going to tell your employer, whether you got this question right or wrong. You don't have to worry about that. But I do want you to pick an answer. So even if you have not been able to completely figure it out, you have to pick out an answer. One, two, three, or four. Okay, for those in the audience there, I want you to all put your hand on your chest, indicating the choice you took. One, if you have choice one, two, if you have choice two, three, if you think choice three is the most likely, and four, if you think option four is the most likely. And now, so that I can see it, because I'm sitting behind you with the camera, please raise your hand, so I can see which choice you had. And if you don't raise your hand, I'm going to ask Fabiana to go to you and make you stand up. And right now, the six people I see in the front, none of them have their hand raised. Okay, I'm counting to three. And if you don't raise your hand, or is the video frozen? I don't know. No, it's not frozen. So raise your hand and show one, two, three, or four. People in the chat have already replied. Thank you. Come on, don't be afraid. Okay, I think the video is actually frozen. That's why. Okay, so now I want you to turn to your neighbors, form a little group, three or four people. I am sorry, people online, this is harder for you, but if you know somebody who's also attending the webinar, get on WhatsApp or whatever. But I'm going to give you 2 minutes to discuss this with each other. Go ahead. Turn to each other. Look at this. I mean, Fabiana just sent me a picture of the aura with people engaged. You got all fired up. I mean, how different is this from the beginning of my lecture where I just, dumped information on you? And I bet that, right now, I mean, I am not here to teach you about probabilities. I'm here to teach you about education and AI, and we'll get to AI, I promise you, in a second. We'll go back to AI. You're probably dying to know what the right answer is to this question. If the question doesn't really, or the answer doesn't really matter because I've already made my point. But I don't want you to lose sleep about this, and so I'm going to tell you what the right answer is. But before I do so, let's analyze what happened here. I asked you a question, and you thought about this question, and I had you make a commitment. I told you you have to pick an answer, one, two, three, or four. And then you had to externalize that answer. You had to turn to a neighbor, and I apologize for the people online who are stuck alone. You didn't get to experience that, but you can probably imagine it. You had to externalize it by telling the person near you, I chose answer, because blah, 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 blah. And in the process, what happened is that you moved away from the answer to the reasoning, the process, highlighting the process over the outcome. And whether you want it or not, you were thinking like a statistician. And if the question was about physics, you would have thought like a physicist. Or if the question was about art history, you would have been engaging in the thinking about art history. But the most important point is this. You became emotionally invested in the learning process. You're not going to let me finish here without me telling you the answer. And there's something else really interesting. Please raise your hand online. Just give me an emoji. Raise your hand if you used AI to answer this question. How many of you actually used AI as a shortcut to answer this question? I have one person here who raises his hand. Thank you for the honesty there. But most of the, I think I see there are 74 participants online, notice did not. Why? Because we have this innate desire to want to figure it out. And with AI, that all goes completely away. And it's actually even worse. AI cannot solve this problem correctly. I tried it. And the reason is that the right answer is, you're not going to like this, it depends. It depends because there's an ambiguity in the question, which I put in there on purpose. And the ambiguity is this word, or. What does or mean? Does it mean it rains in London but not in Chicago, or in Chicago but not in London? Or does it mean those two cases and also the case London and Chicago? In other words, for those of you who are familiar with logic or programming, is it an exclusive or an inclusive or? Nobody asked that question, so therefore the answer is it depends. Here's how you would work it out. Let's look at all possibilities. Same thing we did with the dice, right? There's 70% chance of rain in London and a 30% chance of no rain in London. Of the days that it rains in London, the 70%, that blue part there, 40% are going to be days where it also rains in Chicago, right? Because we know that there's a 40% chance of rain in Chicago. There's also going to be 40% of the no rain days in London, but we'll get to that later. So how much is that? That's a 28% chance that it rains in London and in Chicago. There's also a 40% chance of the no rain when it doesn't rain in London, that it rains in Chicago. So 40% of 30% is 12%. Now, what about rain in London, no rain in Chicago? Well, 60% of the time. Oh, yeah, I wanted to first point out that if you add these two numbers, you get 40%, as you should, right? So luckily, that's correct. So what about the days that it doesn't rain in Chicago, but it rains in London? That's 60% of them. So how much is that? 60% times 40% is 42%. It will be not raining in Chicago. And then of 60% of the no rain days in London, it will also not be raining in Chicago, which is 18%. And as you can see, if you add 42 and 18%, you get 60% of the days that it doesn't rain in Chicago. So this all checks out. So now we can look here and answer the questions one by one. It rains in London. Oh, it rains in London. We already know that. And I'd already told you it's 70%. It rains only in Chicago. Well, then you have to start here with no rain in London, 40%, and you have to see the days that it does rain in Chicago, but not in London. That's 12%. So that's definitely not going to be at the top. It rains in London and Chicago. That means blue in London and blue in Chicago. That's 28%. And now it rains in London and Chicago. And there's the ambiguity, because do you include the days that it rains in both or not? If you do, you get 82%, and that's the correct answer. If you don't, then you eliminate the days that it rains in both, you get 54%, and then the right answer is 1. So depending on how you interpreted the or, either 1 or 4 is correct. And you see, this is something that is really important. ChatGPT doesn't deal very well with ambiguities. The human mind is better at figuring out, oh, there is an ambiguity. Not always, but you can. Okay, so where does this leave us? I already showed you the low self-determination in a lecture. But if you bring in this peer instruction, this interaction, You may have had an aha moment while talking or while getting the explanation or while thinking about this. So there's more of growth. Also, it's not me controlling you, you control you. And lastly, you interact with others. There's a relatedness with others. The key point I want you to take home with you is that this prioritizes process over answer. Now, and also it reduces the temptation to take a shortcut. Now, there are many other forms of active learning. I'm only showing you one here because that's what I have been specializing in. And all have similar outcomes. So you have to find out what type of active learning works for you. If you think about peer instruction, there are different ways of doing it, right? In the traditional lecture, in the traditional approach, the information transfer takes place in class and lecture, and homework and study provide sense making at home. The first option is to do both the information transfer and the sense making in class, like I did with you. I told you about probabilities and then I asked you a question, which I would call an interactive lecture. But then, and this is what I have done, is I moved the information transfer out. Why waste time in class having the students passively sit and receiving information? Let's do that outside of class. They can read or record a lecture. And the third option is to use an interactive platform such as Perusal. I have to disclose here, I developed that myself. It's a free platform used by now close to 6 million students around the world that permits the reading or the watching of a recorded video to be interactive. They do it together with other students and interact asynchronously with each other. I don't have time to talk about it because I want to get to the final part of my talk, which is assessment, and then wrap up. And assessment takes place in two different forms, homework, and then there are, the more high stakes assessments, such as an exam. And I already said, self-determination tends to be low in homework, and with AI, it's completely gone. Why is that? Well, the traditional homework aims really at having students practice whatever they need to learn and make sense of whatever we have presented to them. And the homework typically, because it's an overwhelming workload for the instructor, is evaluated on the outcome, not on the process. So, now that this outcome can be generated by AI, this approach simply does not make sense anymore. And I'm going to propose to you something I use in my own class, which is a revised 3-step team-based assignment. You ask students first to prepare an assignment at home individually. This one is simply evaluated on effort and process evidence, and it's initially simply spot checked. So students don't know if we're going to spot check, so they better do it, because if they don't do it, it evaluates all 3 steps. Everything is 0. So they have to hand in something that demonstrates effort and process evidence. Then they come to class where they come together with their team, and they need to work on improving their work. I need to show my work to my team members. My team members need to show their work. We need to think together, how can we improve this? And how can we make sure that every single team member is capable of presenting the solution that we agree on? Why? Because as an instructor, I'll walk around and I'll say, you, Paula, why don't you present the solution? And if Paula came late, or didn't do her work before class, or has been struggling understanding, she sinks the entire performance of everybody on the team. So that means there's a social responsibility of the students to help each other understand. This is evaluated on the thought process. And yes, in a very large class, I cannot check every single student. I can maybe check 10 students in a 75-minute period, but I cannot check all of them. But over the course of the semester, I get to check every student at one point or another. I keep a list at one point or another in the semester. And then the final part is something that the students do again at home, which is called a calibrated peer review. And you can find information about this online. And essentially, the students evaluate each other's and their own process and their own reflection on what they did. The reflection is there to promote metacognitive abilities. So what is calibrated peer review? I'm going to explain this very quickly and then we'll wrap up. The first step is that students get to see 3 different calibrations pieces prepared by the instructor. One is a really good piece, one is a lousy piece, and one is a mediocre piece. These are typically solutions that students have handed in previous years, and I take some of the best solutions and I make them better, and I take some of the bad solutions and I make them worse, and I just take an average solution. They don't know which is high, which is low, and which is medium. They come in a random order. It's done, it's automated, so it's randomized. But they see these 3 pieces and they have to use a rubric to evaluate these 3 pieces. The rubric is very important. And they get, this is machine scored, it's completely automated. They get evaluated on their scoring accuracy. If they do a bad job interpreting the rubric, because I have also used the rubric to score the calibration pieces, they have to do it again and they get a lower scoring accuracy evaluation. And then they have to do it 2 or 3 times before they're permitted to go to step 2, where they anonymously score the work of 3 peers. This produces a score for each peer, but it also produces an accuracy of their own grading because 2 other peers are also going to score those same pieces. So the system can cross-correlate it. So it provides 2 scores, a score for each of the 3 peers that they score, but also an accuracy of the student who is carrying out the peer scoring. So by this time, after step 1 and 2, the students have seen 6 pieces. And it's so important not just to hand in your work, your own work, and then wait a week and get it back from the instructor saying this is bad or this is good, but to actually see the work of other people, including some that is guaranteed to be very, very good in step 1 and some that is very bad. Maybe you see the piece that is very, very good and you think, this is good, but mine is good too. Or you think, this is good. I wish I had done this. Or you see, this is lousy, I'm better than that. So you can calibrate your own piece on the scale of different performances. And lastly, the student gets to evaluate, themselves. And they do this after having seen all of these other pieces. And the great thing is that, that produces 2 other things, a self-score and a self-scoring accuracy, because 3 peers are also going to score that piece, so it can again be cross-correlated. And eventually, all of these scores are combined to yield a score for the student. So notice that the evaluation now also becomes a learning opportunity. Step 1, you go, oh, I should have done it this way. Or in step 2, when you see somebody else's work, oh, this is great. Or when you see yourself, you think, I really did a good job here. And where does the instructor effort go? Because this is almost completely automated. The instructor effort goes into developing good rubrics and the calibration pieces, which is still quite a bit of work, but it's less than hand grading hundreds of different works. So just to show you some data out of my own class, we had also not only the students rate them, but I had the teaching team, myself and my assistants rate the same pieces. And we compared the scoring accuracy, the scoring by students grading their peers to our grading their peers. And as you can see, you would think maybe students are much less good at grading than we are. No. 2/3 of them agree with the way we score them. A few, a little over 10%, overrate them, and 20% underrate them. So if anything, they're tougher. And, this is probably as good as you can get between the agreement between to instructors grading the same work because there's some subjectivity in it. And then finally, the self ratings, you see a little bit less under rating, but again, a really good agreement. And the reason is probably because when you look at your own work, you know what the thought process was, well, because you were the one thinking. So it's easier to interpret your own work than that of peers. So this, just to tell you, you can actually do this in a meaningful way, self and peer scoring. And there are, many other benefits. Oh, pardon me. I should go back. Why is my screen? It seems that the video, there we go. So there are other benefits. There is an increase in metacognitive abilities, understanding your own learning better. Students report that they find calibrated peer review helpful for their learning. There's increased self-determination because they are in control. And the good thing is it's scalable. Okay, we're getting to traditional exams, which I'm going to be very short. There's no self-determination whatsoever. I mean, if you look at the picture in the background, you probably already get stressed out just looking at it, thinking of when you were a student. I have eliminated exams from my course completely. I don't think it tells us what we need to know. I rely on the in-person discussion I have with my students and the feedback I get from the calibrated peer review. Before I did that, I had two-stage assessments, and if you're not willing to eliminate all of the exams, you should look in two-stage exams or two-stage assessments. The first part, students answer questions individually, looks like a traditional exam, but then you have them get together with their team and they work in the team to improve their performance. And you can even gamify that using a technique called Readiness Assurance Test, RAT, that produces a team score, and then students' individual scores, the student score, will become the average of the individual and team score. So students really have a motivation to first do as well as they can individually, because that's half their score. And then they have an incentive to get the team to do as well as possible. You need to make this hard enough so that no students gets all answers correct individually. Because if you do so, if you have a student who gets all questions here correctly, then that will influence this. Students are just going to follow the best students. You have to challenge even the best students. And here again, it turns the assessment into a learning opportunity, because as they work with their team, they'll go, oh, yes, you're right. I should have done this or I should have done that. Okay, let me wrap up here. I showed you that with two-stage assessment, we have assessment for and not just of learning, that we have increased self-determination, and that because it can be auto-scored, it is scalable. It's something you can do in your class with the proper tools. So let me wrap up here. We've talked about, education in the age of AI, but AI can also be a phenomenal instructional partner. You can have AI help you to discern better learning outcomes, to develop rubrics and assessments, to plan your curriculum, to develop case studies and project ideas, to provide feedback. I have done this. I'm on sabbatical this year, so I thought about the course I'm going to teach next year. And let me show you, I took my old learning outcomes and I asked ChatGPT to help me reformulate my learning outcomes so they would all have an action verb that scores at a given level of Bloom's taxonomy: recognize, blah, 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 integrate, blah, blah, blah. So I tell the students, after completing this course, you will be able to, I made sure that they had definitive action verbs there, and that they had a subject as what it is the action should be. Recognize major research questions. This is a seminar-based course, and methods across several physics subfields. Integrate AI into research and study practices. And the black then gives you the context. by surveying the research literature and attending weekly department seminar, by using AI to read, organize, and communicate scientific literature while critically evaluating its limitations and maintaining academic integrity. Before I show you this slide, did I cheat by doing this? No, I made my course better. And after doing this, I asked it to help me develop rubrics to assess these different parts. And then I asked it, help me design an assessment. So I am using AI to improve my capabilities as a teacher. And therefore, we should also think about the AI student partnership. What do we want students to do with AI? And I urge you to look at this AS scale, AIAS, which is the AI assessment scale. The reference is at the bottom of the slides, and you will have access to my slides shortly, which shows 5 levels of partnerships between students and AI. One, and I am very sorry to say, I see more and more people say, we should stick there, no AI. You must not use AI. But then working all the way up to using AI for planning, using AI to assist with specific tasks, to using AI extensively, to using AI creatively. And I tell you this, I urge you to go as high as you can on the scale. Because if you don't, then your students are not going to be able to find a job because AI can do the job for them. What's more, you're going to end up devaluing the university degree in the age of AI. You're going to devalue it for your course, for yourself, for your students, for your department, for your institution, for your country, for the world. Because in order to retain the value of a university degree, we must cultivate meaningful AI skills. So summarizing, focus on motivation and activation, think about self-determination. In terms of your students using AI, think about the AI scale that I just showed you and what you want to accomplish in your course. And above all, emphasize process over the outcome. I haven't had a chance to post my slides right now. I will post them very quickly. They will be at this URL, so you have all of the references. Thank you so much for your attention. I wish I was there in person. I love Peru, so I hope that in the future I'll be able to come back and tell you much more about all of these details, because this was sort of a broad overview without being able to get into more depth. But I hope I've inspired you to go high up on the IA scale and to focus on process, not outcome. Thank you so much. Be well.